Here we have another system of equations, and again we have a quadratic and we have a linear. So when I graph these two, my quadratic is going to go something like this, and my linear is going to look something like this. And what I'm looking for is I'm looking for the intersection of these 2 points. So that means I'm looking for an xy value. So x is my input, so if I can solve for x, then I can find my y. So the thing to remember with substitution is if I have y equals y, that means both my equations are equal to each other. So that means I can rewrite this to be 5x squared plus 9x plus 4 is equal to negative 5x plus 3. Because I have a quadratic, the way I solve my quadratic is to make everything equal to 0. So I'm going to move the right side of my equation to the left side because my lead coefficient is positive and I want to keep it that way. Which means I'm going to add 5x, and I'm also going to subtract 3. I'm going to do this in one step. You can do it in 2 steps. I just want to show you that there is a slightly faster way of doing it. So the 5x squared comes down, and I have 5x squared. 9x and 5x is 14x, and then 4 minus 3 is a plus 1. And then that equals, well, this 0 and that 0, so that equals 0. So remember, 0 is a number. You must write it down. So now I'm going to try to factor this. So I'm going to do my factoring by grouping technique, and I'm going to do 5x squared times 1, which is 5x squared, and I'm going to put my middle term here. So if I'm looking for my factors of 5x squared that add up to 14, I am not going to be able to do it because my only factors of 5 are 1 and 5, and there's no way that that will ever give me 14. So this means that I can't factor. If this doesn't work, I can't factor. That means that this here is prime. But that doesn't mean that I'm stopped from getting a solution, because I have this wonderful tool called the quadratic formula. So I'm going to use the quadratic formula. So notice this is not quadratic form. It's not a quadratic equation. It's a formula. And it's going to help me solve for x when y is 0, so to speak. So I'm going to put x is equal to, so now I'm going to put in my quadratic formula, which is negative b plus or minus the square root b squared minus 4ac. That entire thing is in the numerator, and in the denominator I have 2a. So I have to make sure I have my a's, my b's, and my c's. So remember, standard form of a quadratic is ax squared plus bx plus c, and I have 5x squared plus 14x plus 1. So that tells me that a is 5, b is 14, and c is 1. We just look at the position. So these are the numbers I'm going to use in my quadratic formula. So make sure you write down x equals. So I'm going to have negative b. I'm going to put b in parentheses. b is 14 plus or minus the square root of b squared minus 4 times a, which is 5, times c, which is 1. And that's all divided by 2 times a, which is 5. Take the time to write this out like this. It will save you hours of headache. Okay, so now what we have to do is we're just going to do the discriminant. And that discriminant, if you remember, is this part under the radical. It does not include the radical. So I'm just going to write here, just to remind you, that's the discriminant. And I'm going to do that part in my calculator. So this is going to be x is equal to negative 14 plus or minus the square root of something all over 10. So in my calculator, I'm going to put just the discriminant, 14, and the reason I'm putting my b's in parentheses is just in case I have a negative value, I get it correct, minus 4 times 5 times 1. I didn't have to put that 1 in there, but I just did that for ease. So you can see there's no square root, it's only what's under the radical, so that gives me the square root of 176. So now I have to simplify that square root of 176. So let's kind of do that over here on the side. So if I have the square root of 176 and I want to find my factors that are a perfect square, I'm going to do 176 divided by x, and that gives me all of my factors. So now I have to look for the largest perfect square that I have. Well, I have 4, 9 doesn't work. Look at here, I have 16. Okay, so I know that there is the square root of 16 times 11. 11's prime, so I'm pretty sure that's my largest. So that's the square root of 16 times the square root of 11. The square root of 16 is 4, so that's 4 square root of 11. There's another way that you can find your perfect squares, but because most of you are struggling with just finding the factors on the calculator, and with this, I'm just going to keep this practice for now until you get a hang of things. So that means that this square root of 176 is equivalent to 4 square root of 11. So that means I'm going to rewrite this to be x is equal to negative 14 plus or minus 4 square root of 11 all divided by 10. But now I can still simplify because I know that 14 and 4 and 10 are all divisible by 2. So I can actually divide everything, all these terms, by 2. So then that gives me x is equal to negative 7 plus or minus 2 square root of 11 over 5. So I have two values for x. I have a positive value and then this positive root, and then I have this negative kind of root or path. So remember, I still have to find y, and you might be thinking, oh my god, that is so scary. But sometimes when you just work these out, it's not that scary. So let's break our x down into its two parts. Negative 7 plus 2 square root of 11 all divided by 5 is 1x, and then the other x is negative 7 minus 2 square root of 11 all over 5. So remember, I'm going to take the easier equation, which when I look at these two, the linear is definitely the easy route to go. So I'm going to put y is equal to negative 5x plus 3. That's what I'm going to substitute my x into on both of these, and then I'll get my value of y. When we do it, you'll see it's not that scary. So this is y is equal to negative 5 times x plus 3. Well, what was my x? This is my x. So that's negative 7 plus 2 square root of 11 all divided by 5. Well, here we have 5 divided by 5. Well, that's great because 5 divided by 5 makes that turn into a 1, and I no longer have a fraction. Now I just have to distribute in this negative 1 right here. So when I distribute in that negative 1, that's going to change all the negatives to a positive. So that means now I have y is equal to 7 minus 2 square root of 11 plus 3. This plus 3 is on the outside. My 7 and my 3 are like terms, so that means I have y is equal to 10 minus 2 square root of 11. So I'm now going to write this as a coordinate. So that means that my answer is, well, what was my x? This was my x plus 2 square root of 11 over 5. And what is my y? 10 minus 2 square root of 11. So that there is one solution. So I just have to do the same thing on the other side. And you can see it wasn't that scary. It just looks really funny. So over here, this means I'm going to do y is equal to negative 5 times x plus 3. And remember, x is negative 7 minus 2 square root of 11, all divided by 5. Don't panic. These 5s divide out to 1. And then I'm just left with a negative. So this negative distributes to the inside. So then that leaves me with y is equal to 7 plus 2 square root of 11, and then I have this plus 3. Excuse me, plus 3. 3 and 7 are like terms, so I combine them. I get 10 plus 2 square root of 11. So that means my other point is, well, what was my x? My x was negative 7 minus 2 square root of 11, all divided by 5, and my y is 10 plus 2 square root of 11. So that's my other solution. So I just want to tell you that you have all the skills. Everything we've learned so far this year has come together in this one problem right here. And the number looks funny, but the techniques are exactly the same. So just go with the process, and you'll be fine.